Good morning, students. We'll start with the today's lecture. In the previous lecture, we have started with the second chapter, block diagrams and signal flow graphs, right? Okay, and we have seen the what is block diagram, and we have taken the example of liquid level control system, right? Then we have represented how to represent in terms of block diagram that we have seen, and we have identified the blocks: controller, plant, input, output, feedback, all those things, right? And we have represented. Then block diagram algebra, we have seen addition, subtraction, and multiplication with right. Then we have started with the block diagram reduction rules, right? So those block diagram reduction rules will help us to reduce the number of blocks, right, and make it only the single block with input and output. Okay, we have started with that and we'll continue. Already four rules are covered. Okay, we'll start with rule number 5 and 6. Okay, just for revision, the first second rule speaks about the blocks are in series or cascade, first rule. Then blocks are in parallel, second rule. Third and fourth rules: moving the summing point after a block and moving the summing point before a block. SABD: summing point after a block has to pass through direct gain block. Summing point before a block has to pass through inverse gain block. SABD, if you remember, right? I have given the hint yesterday. Okay, we'll start with the rule number 5. Moving the takeoff point after a block, rule number 5. And rule number 6, moving a takeoff point before a block. Okay, what are the, just we'll see one by one. Okay, there is this, we know what is takeoff point, also called as branch point, right? Okay, the signal goes concurrently to the other blocks or summing point, right? This we call it as takeoff point or branch point. Yes, takeoff point is here and block is here. I want to shift this takeoff point after a block. Okay, what will happen, we'll see. Okay, takeoff point, it has moved after a block here, and a block is here, and takeoff point is, yes, we have moved the takeoff point after a block. Just observe, if I move the takeoff point after a block, the signal is passing through inverse gain block. So in order to remember it, I have given in green letter TABI. Takeoff point after a block has to pass through inverse gain block. TABI, you can remember like this. If the takeoff point is moved after a block, it has to pass through the inverse gain block. If it is G here, it is 1 by G. You got it? Okay. Then next, we will go to the rule number 6. If I next observe this diagram, block is here, takeoff point is there. I want to shift the takeoff point before a block. I want to shift the takeoff point before a block. Okay. Yes. If I want to shift the takeoff point, let us have a look at this diagram. Right? Okay, takeoff point has been taken here before a block and block is here, right? Then what are the changes? Observe here, if I move the takeoff point before a block, it has to pass through the direct gain block, G. Here it has, in the first case, fifth rule, it is passing through inverse gain block. Here it is passing through the direct gain block. So in order to remember it, TBBD, if the takeoff point, if I want to shift the takeoff point before a block, it has to pass through the direct gain block, right? TBBD. You remember anyone? TABI, takeoff point after a block has to pass through inverse gain block. Takeoff point before a block has to pass through direct gain block. You remember like this, right? And summing point and block we have seen, SABD, just for recalling yesterday's. If I shift the summing point after a block, it has to pass through direct gain block. If I shift the summing point before a block, it has to pass through inverse gain block, right? This we have seen, right? Takeoff point and block we have seen, these two rules. Now we will proceed with a few more rules. Totally 13 rules are there. Yes. Seventh rule, eliminating a feedback loop. This already we know. This is the simple closed loop system. It has G forward path transfer function, H is the feedback path transfer function, X1 and X2 are the outputs, and this is the summing point. If I want to eliminate the feedback loop, we have obtained the transfer function of the closed loop system yesterday, right? So G divided by 1 plus GH. If it is negative here in the denominator 1 plus GH, if it is negative, but they have taken plus minus, so I am getting minus plus. You are right. If it is plus here, it will be minus. If it is minus here, negative feedback system, it will be plus here, right? So G divided by 1 minus plus GH. The input is X1, X2. This rule we know, right? The next, interchanging summing points. Eighth rule. So we have to thoroughly learn all these rules so that we can reduce the block diagram very easily, right? Okay, interchanging summing points. When this question will arise, when there are more than one summing point, right? Okay, I have two summing points. I want to interchange. Let me call this as first summing point, this as first summing point and second. I can interchange the first and second, right? Just observe here. The first summing point has the signals x1 and x2, either added or subtracted. Then second summing point has two signals once again, x1 plus x2 and x3. So finally, the addition or subtraction, x1 plus or minus x2 plus or minus x3 I am getting. Just interchange the summing points, the addition of the signals which gets altered, that's all. First x1 and x3 are added, then x2 is added, that's all, right? First x1 and x2 are added in the first case. Here after interchanging, x1 and x3 are added, right? The addition doesn't matter, right? Okay, we can interchange the summing points very easily, no problem. Okay, next we'll proceed to the next ninth rule, splitting a summing point. When we go for splitting a summing point, suppose the summing point has more than two signals, or more than two signals means 3, 4 and so on, like that, right? Here you can observe in this diagram, the summing point, it has three signals, x1, x2 and x3, right? At this case, I will go for splitting a summing point. One summing point has got, instead of one summing point, I will make use of two summing points. Every summing point, in every summing point, I will add two signals. First, I will take the first summing point, I will add the signals x1 and x2. I will take the second summing point, I will add the third signal x3, right? Totally three signals we are added by making use of two summing points. So this we call it as splitting a summing point, right? Yes, but this is not preferred. Sometimes it is preferred, sometimes it is not preferred, because it is increasing the hardware. Only one summing point is actually some sensing device, it is, right? So we are making it two. But if the situation or demands, then we have to go for splitting a summing point. It is not mandatory that we have learnt all the 13 rules and we have to apply all the 13 rules for a particular problem. Based on the situation, whichever the rule that is suitable for reduction, that we have to apply. Is it fine? Okay, next we'll proceed to the 10th rule. Moving a takeoff point before a summing point. Yes, the rule is concerned with, earlier we have seen summing point and block, takeoff point and block. Summing point and block, two rules, takeoff point and block, two rules. Here the 10th rule, takeoff point and summing point. Observe here, this is summing point is here, takeoff point is here, right? Observe the movement here, takeoff point is here, sorry, this is summing point and this is takeoff point. So what does this rule say? Moving a takeoff point before a summing point means I want to shift this takeoff point before this summing point, right? Shift the takeoff point before the summing point. Just observe here. Okay, 11th rule also I will go through. I will go to 11th and I will compare both 10th and 11th rule. Observe here, moving a takeoff point after a summing point. Takeoff point is here. I want to shift it. I want to shift the takeoff point after a summing point, right? Whether I shift the takeoff point before a summing point or after a summing point, one more summing point gets added. Two summing points are coming here. You can observe in rule number 10 and 11, right? Okay, first we'll see the rule number 10. Shifting the summing point, taking the moving a takeoff point after before a summing point, right? Okay, I am shifting here. Yes, summing point had come here. Okay, if the summing point had come here, one more summing point, sorry, takeoff point had come here, one more summing point gets added. But the output should remain the same. Here you observe the takeoff point, the signal is x1 plus or minus x2. The takeoff point had come here. Yes, one more summing point gets added, but the output should remain the same, x1 plus or minus x2, because the output of the takeoff point here, the signal that is going from the summing point is x1 plus or minus x2, same as the output here. So the signal has to remain the same, x1 plus or minus x2. But observe here, just x1 at the input side, x1 is coming and it gets added here at the summing point. But I want the output to be maintained, so I will add the another signal plus or minus x2. I hope you got it, right? So whether I move the takeoff point before a block, before a summing point or after a summing point, one more summing point gets added. The hardware increases. Please keep in the mind, takeoff point and summing point. So this is rule number 10. Then rule number 11. Yes, if I shift the takeoff point after a summing point, takeoff point is here, this is summing point. I want to shift this takeoff point after a summing point. So if I shift the takeoff point after a summing point, one more summing point gets added. You can see here that takeoff point had come here. Then observe here, at the takeoff point the output is x1. So the takeoff point has shifted here. At the output I should get x1 only. Just let me check it, right? Here the input signal is x1 plus or minus x2 is coming, but I want only x1. So subtract the another signal. So minus plus x2 you add it, so that I will be getting x1. Means if I apply any rules, the functionality should not change, right? The signal should not be affected. I should apply the rules in such a way, right? Okay. Totally 11 rules are covered now. Rule number 12 and 13 are there. We are not using this rule number 12 and 13, but we should be knowing it, right? 12 and 13, just formality's sake, we will cover here. Removing a block from a forward path. This rule number 12. Okay, there are two forward path transfer functions, g1 and g2. The input is x1 and output is x1 g1 plus or minus g2. Here what is the rule, what it is saying? Removing a block from forward path. So this is forward path, right? So this is forward path. From here it goes to g2 and it is going to and it gets added to summing point. So the G2 is the forward path. I want to remove this block from the forward path. This is the forward path. You can observe here. This is the forward path, right? So I want to remove this block G2 from the forward path. Just observe here. Yes, it is removed here. Just the straight line has been drawn here. Now what happens if I remove this? If I remove it, what it will divide, and see here, it gets divided. Whatever the block is there, another block, it gets divided there. It divide this G2 and G2 will come here. But the output remains the same. Just you can check it, right? Just let me verify it here. Okay, whether I'm getting the same output or not, x1 g1 plus. See here, at this point what I'm getting, x1 into g2. Okay, here what I'm getting, just let me check it, x1 into g2 into g1 by g2 into g1 by g2. Here I am getting at this point. So g2 will get cancelled, x1 into g. So x1 into g. What about this, x1 into g2? So x1 into g plus or minus x1 into g2. Here x1 into g2, right? I am getting the same output, right? So the block has been removed here. The block is not there here, right? It has been removed, but that blocks goes here before, right? And also it divides the gain in the forward path or main path, right? Okay, but we are not using this rule much. But let it be, we will study. Then 13th rule, last rule, removing a block from a feedback path. Just observe the given diagram here. Yes, x1 is the input, summing point is there, g is the forward path transfer function, h is the feedback path transfer function. Output is x1 into g1 minus plus gh, right? This is the output. Okay, I want to remove a block. This block I want to remove. This block has to be removed from a feedback path. What to do? Just observe the changes. Yes, you can observe the next diagram. Yes, it has been removed here. H has been removed. If H has been removed, what will happen? So here, in the earlier case, we have removed from forward path, but this is feedback path. So if I remove the block H here, it will go here and it will become 1 by H and it gets multiplied here. In the earlier case, it goes here as g and it gets divided here, but here it goes as inverse 1 by h, 1 by that gain of the block, and the gain gets multiplied here. Please remember, compare rule number 12 and 13 so that you can remember, right? Okay, we have studied all the 13 rules. We will summarize all these 13 rules here. Okay, the summary. What are the rules we have studied? Totally 13 rules we have studied. Just I am summarizing it. Is it fine? Okay, rule number 1 and 2. They speak about the blocks are in series and the blocks are in parallel. Right? These are the two rules. These are the two rules. Then next, another two rules speaks about the summing point and block. Just to recall, okay, if the blocks are in series, we will multiply the gains. If the blocks are in parallel, if there is addition, we will add them. If there is subtraction, we will subtract them. Then next, rule number 3 and 4. 1 and 2 are over here. 1 and 2. Next, rule number 3 and 4 here. Summing point and block. Just to recall, if summing point is moved after a block, it has to pass through the direct gain block, SABD. If the summing point is moved before a block, it has to pass through inverse gain block, SBBI. Right? You remember like this, SABD and SBBI. Then 3 and 4 are over. Next, rule number 5 and 6. Takeoff point and block. Yes, I have a takeoff point and block. If I want to shift the takeoff point after a block, it has to pass through inverse gain block, TAB. You remember like this, TAB. If the takeoff point has to be shifted before a block, TBB, then it has to pass through direct gain block. Exactly opposite, right? You can remember very easily. You remember only one thing. You remember SABD here, you remember TAB here. The other one will be opposite. Then 7th rule, feedback loop. Yes, we know that how to eliminate the feedback loop. Closed loop transfer function, right? G divided by 1 plus GH if it is negative feedback system. Then next, rule number 8, interchanging summing points. Yes, if there are two summing points, first summing point and second summing point, I can easily interchange, right? That we know. Then next, rule number 9, splitting a summing point. When there are more than two signals, suppose there are three signals, then I will split that single summing point into two summing points, and each and every summing point I will add two signals, right? Totally the signals are taken care. Then next, another two rules, rule number 10 and 11. Yes, summing point and takeoff point. Whether the summing point is moved, whether the takeoff point is moved after a summing point or whether the takeoff point is shifted before a summing point, one more summing point gets added. The hardware increases. Please remember. You know what is takeoff point and what is summing point. If I shift the takeoff point after a summing point, or if I shift the takeoff point before a summing point or after a summing point, one more summing point gets added. Please keep in the mind, right? Then next, rule number 12 and 13. 12 and 13. Removing a block from forward and feedback path. Yes, just now we have seen, right? Okay. Well, then we'll proceed with the numericals. We'll solve few numericals on the block diagram. Is it fine? If any doubts, please unmute yourself and talk to me so that I can clarify your doubts, right? Don't keep the doubts with you. Okay. Example 3.1. Obtain the transfer function of the control system whose block diagram is shown in the figure by block diagram reduction technique. Yes, they are. This is the block diagram they are given. You can observe there are several blocks are there: G1, G2, G3, G4, H1, H2. Several blocks are there, and several summing points are there. 1, 2, 3 summing points are there. The input is R and output is C, right? So finally what I have to do, I have to convert it into a single block having input on the left side and output on the right side, right? By using the block diagram reduction technique. So obtain the transfer function of the control system, right? We are using the block diagram reduction technique in order to obtain the transfer function of the given system, right? Okay, this is the system block given and it is represented in terms of block diagram. Okay, just observe here. If you want to note down, please note down this block diagram so that we have to reduce it. We have to write the explanation of reduction. What will happen? We have to see, right? We will do one by one. I hope, please note down this block diagram, or else please listen here, or else later on you can go through. Yes. Okay. I will read the question once again. Obtain the transfer function of the control system whose block diagram is shown in the figure by block diagram reduction technique. So one more technique is there in order to reduce this block diagram by signal flow graph technique or signal flow graph method that we will be seeing next. The same block diagram, whatever that has been given, it can be solved by two methods. One method is block diagram reduction technique. Another method is signal flow graph. We call it as SFG, signal flow graph. We will see it later. What is signal flow graph, right? How to solve this? We'll see it, and we have to get the same answer. Whether I solve by block diagram reduction technique or signal flow graph method, I have to get the same transfer function. We'll see it later. Okay, fine. We will apply the rules one by one. Always the rules should be applied in this manner. Okay, this is, we should look for the blocks which are in series and parallel first, then we have to eliminate them. Then after looking for the series and parallel blocks, next we have to think of whether there is summing point and block, whether to shift the summing point after a block or before a block so that the block diagram gets reduced in this order only. Then next, if there is any takeoff point and block, I have to shift it appropriately, whether takeoff point after a block or before a block, that I have to take care. If there is any feedback loop, that I have to eliminate using the rule, right? This is one thing. Then if there is any requirement of interchanging the summing points, that also I can do, right? Based on the requirement, apply the rules and reduce the block diagram. Is it fine? Okay, this is the given block diagram and I will apply the rules. Okay, just I will search for the blocks which are in series or parallel. Here you can observe here, yes, they have shown the dotted line here, right? You can see here. It is not given in the, but okay, we will just draw the dotted line so that it acts as a hint for you people. Okay, you can observe here the blocks G2 and G3 are in parallel. So I will write the blocks of first write the explanation, then go for reduction. Don't just directly do it. You have to write in wordings. The blocks G2 and G3 are in parallel. Okay, if blocks G2 and G3 are in parallel, what will happen? Just observe here. G2 is going to this summing point and the sign is plus, and G3 is going to this the same summing point but it is minus. So two blocks are there, G2 and G3, and it will be converted to single block. I will write it here. What is that single block? G2 minus, because G3 it is minus, so G2 minus G3, and it gets converted to single block, right? This is one rule we have applied. I hope you got it, right? Okay, these two blocks are eliminated and this summing point also vanishes after applying this rule. The blocks are in parallel. So G2 and G3 vanishes and the summing point vanishes and I am getting the single block, that is G2 minus G3, right? Then next, if I am getting the single block G2 minus G3, then this block G2 minus G3 is in series with G1 right here. I want to apply more than one rules and reduce it and write it, right? Okay. Okay, G2 and minus G3 is here. And this G2 minus G3 block is in series with G1. So I will write one more thing. G2 minus G3 block is in, so one by one I will write. point 1. This is second point. G2 minus G3 block is in series with block G1, is in series with G1. So if they are in series, I can multiply the gains and make it single block. G1 is another block with G1, right? So just multiply them. So G1 into what it will become? G1 into G2 minus G3. Okay, this is the single block what I am getting after applying. So apply this first and second rule and I will redraw the block diagram, right? Remaining thing I will keep it as it is. So I will go to the next slide. So R as it is, summing point as it is. Next, this entire thing, just I will round it. I have applied the rule. So I am getting single block G1 into G2 minus G3. G1 into G2 minus G3. C is the output, right? But other blocks are there, I have to take care of them also. H2, then one more summing point, H1, and it is coming from the output. Yes, a sign is plus and here it is minus, here it is plus, here it is minus, and here it is plus. Okay, one more G4 is there, it is going to the summing point, G4 from input, G4, it goes to this summing point with negative sign. Yes, I have taken care. This entire thing has been reduced in the circle, right? That explanation I have written here. After applying these rules, the block diagram, this is the reduced block diagram after applying those two rules, right? Reduced block diagram. But this is not the complete reduced block diagram, right? So still I have to continue. Okay. Okay, next. First, second is over. Next, I will apply the third one and based on my observation, what we should do. We'll think of. Right? So next, any blocks are in series here? No, I cannot find. Any blocks are in parallel? I cannot find any blocks. Then summing point and block. Yes, we will think of summing point and block. See here, the block H2 is there and this summing point is there. I can shift the summing point after a block. I am calling it as after because I am moving like this. Summing point after a block. Shift the summing point after a block. What will happen? You see here, the summing points come here, block H2 will come back here. H1, H2, they will come in cascade, right? If I shift the summing point, okay, I will write here, shift the summing point after the block. So these all things will come by experience. Means you have to solve more number of problems. First, have a look at the worked examples in the given textbook of Anand Kumar, right? Have a look at which rule he has applied. Please keep in the mind. Then based on your experiences, you will come to know which rule I should apply and how the block diagram gets reduced. So the only way is you have to solve more number of problems. Initially you have to observe a lot for the few problems so that you will come to know, right? If any doubts, please clarify with me. So I will write here, shift the summing point after block H2. Shift the summing point after block H2. Yes, if I shift the summing point after block H2 means we know this rule. Summing point after a block has to pass through direct gain block, SABD, right? Direct gain block. Right? SABD. If I shift the summing point after a block, it has to pass through direct gain block. Okay, let me assume what will happen just here. See here, I am shifting the summing point after this block. So this G4 has to pass through this direct gain block. H2 will come here, right? It has to pass through this. So I will take some other color ink and I'll show you. You don't make the changes here only. So H2, it has to pass through direct gain block, right? H2, it is passing like this. This summing point gets shifted here. This H2 comes here. Is it fine? I hope you are getting. So H1 and H2, they will come in series. G4 and H2 means because summing point After a block has to pass through direct gain block. This G4 is passing through this direct gain block, right? H2 is the gain, so it is passing through direct gain block, right? So I will apply this rule and I will rewrite. So next, reduce block diagram, observe it, how it will become, just observe it. I am drawing it. Is it fine? Yes, this is correct. Next, G1 into G2 minus G3. Okay, observe here what I am doing. Yes, summing point has to come here because I am shifting, not H2, right? So summing point had come here. Then next H1 and H2, they will come in series. H2 has come back here because summing point is coming here, right? We have shifted the summing point after block H2. Yes, it had come after block H2. Then H2 and H1, they will be in series now. Then it is coming from the output. Then next, yes, I have shown here from output, sorry, from input, it is passing through this G4 block, G4. If I shift the summing point after a block, it has to pass through direct gain block, which is that block H2, right? So it is H2. Then it gets added to the summing point. Right, it is minus here. Please take care of the sign. And it is plus here. So it is minus here, right? Please take care of the sign, and it is plus here. We have taken care. Okay. So this is the reduced block diagram after applying this rule number after step 3, right? Reduced block diagram. Reduce block diagram. But this is not the complete reduced block diagram, right? Reduced block diagram. The next, fourth point, we will think of some other rules. Once again, I will observe this block, the reduced block diagram, and we'll think when any blocks are in series. Yes, these two are in series. Just I will take some other color and make dotted. Yes, H1 and H2. These H1 and H2 are in series. I will make it single block. Then G4 and G2 are in series. I will make it single block. I will write that rule. So H1 and H2 are in series. If they are in series, it will be converted to single block. Just multiply the gains of the block H1, H2. Okay, we have applied this. Next, fifth. Next, G4 and H2 are in series. G4 and H2 blocks are in series. If they are in series, they will be converted to single block, multiplying their gains G4 into H2. Is it fine? I will redraw the block diagram once again. Observe here. After this, I will redraw it. So do step by step. I hope it is clear till here. If any doubts, please unmute yourself and ask so that I can clarify your doubts. This is time consuming process. Anyhow, but this is the only method in the block diagram we have to do this way only. There is no other alternative, right? Okay. Next, the summing point comes over here. And here the block will be single, that is H1 into H2. I am redrawing it. Next, G4 H2. And observe the sign here, it is minus, and here it is plus. Yes, this is the reduced block diagram, but this is not the complete reduced block diagram. Reduced block diagram. Okay. Next, we'll try to apply any sixth rule. Already 5 rules we have applied. Means 5 steps, 6 steps. What we'll do? How to reduce? Okay, I'll change the ink. Okay. Next, you can observe here from this takeoff. There are 2 summing points, right? So I want to interchange the summing points so that you can observe here. If I get the blocks like this, just I will draw roughly here, right? If this block becomes like this and there are 2 separate parts, that will be easy for me, right? One summing point here, one summing point here, right? so that this will be feedback. I can solve very easily. Roughly I have drawn here, right? So I want to interchange the summing points. So next I'll write interchanging summing points. This is very important. Please observe, right? Interchanging summing points. So this summing point, what it is doing? Just the sign is, I have not written the sign here. It is minus here. Just observe here. This is minus. So I have to write minus here. Be careful, right? The sign is very important. You should not miss it, right? So minus here I have not written, right? Minus. For summing point, please show the sign. That is very important, right? And direction also, you show the direction also. So interchanging summing points. Interchanging summing points. Okay, we will apply this rule and we will reduce the given block diagram. Just observe here what I am doing. So just this will come by experience or practice, I told. Just observe what I am doing and I will explain, right? Okay, this summing point will go here and this summing point will come here. They get interchanged, right? Interchanging summing points, right? So just I will interchange and write. Just observe what will happen. Is it fine? Right? So this is R. From R, G4H2 is there, this block, right? This G4H2, right? It becomes independent just like this. I told no, we can separate it like this. This is one separate, right? So I am doing like that. Just observe here, and there is a summing point over here, and this gets separated, G4H2. But observe the sign here. This is very important, right? So here, G4H2, it gets added here. The sign is minus here, but I am interchanging. Go once again. Minus, this sign you take care, minus, and once again it is minus. Minus into minus, it will be plus. So it will become plus. This is never told in the application of the rule there, right? This will come by practice or experience, I told, right? So just observation. You have to observe several worked examples and you have to listen to our lecture so that you will understand, right? Okay, the arrow mark. This is fine. This along with the summing point, it has shifted. So it becomes independent like this. From this summing point to the next summing point, right? It is coming here. Is it fine? Then we have this block G1 into G2 minus G3. I hope you are observing carefully what I am doing. The next H1, H2, right? So it becomes independent just like this. This already one, it has become independent. So this will also become independent. Just observe here. H1, H2. The next, observe the sign here. Here it is plus. What about this? Here it is minus. You have to take care of this plus because we are shifting, right? So plus into minus, minus. Please be careful. And this is plus. Observe from here to here it has to go plus. Plus is here, right? Then next here it is minus. Plus into minus, minus. So here it is minus. Okay, whether we have separated, we have applied the rule interchanging summing points. After applying this rule interchanging summing points, the reduced block diagram is as follows. This is the reduced block diagram. Okay, still it is not over. Yes, you can observe here. If nothing is there, if block is not there, the gain is unity here. It is 1 always, right? If there is no block or forward part transfer function G1, G2 or something like that, the gain will be unity or 1 always here, right? Okay, just observe this 7th point. I will apply the rule. This block 1 and G4H2, these two blocks are in parallel, right? So instead of 1, I can see I can write the block as block and mention it as 1, simply 1, right? The block here with gain 1, there is one more block, and another block is G4H2. These two blocks are in parallel, right? So the block with gain, I will write here the block with gain 1 and block G4H2 are in parallel. If they are in parallel, what will happen? Just observe the sign here. 1 plus G4H2. 1 plus G4H2. So it will become a single block. This entire thing vanishes. Just I will use another color ink. You can observe here. This entire thing will vanish. Just I will circle it. Observe here. this entire thing will vanish and get converted into a single block. The summing point also goes. So block with gain 1 and block G4H2 are in parallel, and I am getting 1 plus G4H2. This entire thing will vanish. Next I will apply one more rule. Just I will take red ink. Okay. Here the block G1 into G2 minus G3 H1 H2, it is feedback loop. I know how to eliminate the feedback loop. This I will treat it as G. I will use some other color ink so that it will help you to understand, right? Okay, this G1 into G2 minus G3, I will treat it entire thing as G and H1 H2 as H, right? So I am treating this G1 into G2 minus G3 block as simply G, just for convenience, and H1 H2 as simply H. So G and H, we know how to eliminate the feedback loop. So if I want to eliminate this, so we will apply the eliminating the feedback rule. G divided by, here you can observe here feedback, here negative feedback system. So G divided by 1 plus GH. What is G? G is here G1 into G2 minus G3. What is H? H is H1 into H2. So I will reduce. So I will write the rule. So eliminate the feedback loop. Eliminate the feedback loop. So after eliminating the feedback loop, what I am getting? G divided by 1 plus G. So what is G? I will write, instead of G, it is G1 into G2 minus G3. This is G. G divided by 1 plus GH. G is nothing but G1 into G2 minus G3 into H1 H2. I hope you are getting what I have done. So this will be converted to single block. Right, this entire thing after eliminating the feedback loop. So I will redraw the block diagram once again. Is it fine? Okay, let me redraw it. 1 plus G4H2 will come here, or 1 plus G4H2. Next, yes, we have reduced this, so I will multiply and write G1 into G2 minus G3. Just I will multiply and write it. G1 G2 minus, just I am multiplying G1 G3 divided by 1 plus, observe here, I will multiply G1 G2 H1 H2, G1 G2 H1 H2, plus into minus minus G1 G3 H1 H2 minus G1 G3 H1 H2. Yes, this is the reduced block diagram, but still this is not the complete reduced block diagram, right? So next, these two blocks, the above two blocks, which now I am in step 7 is over. Next step 8. So two blocks, the above two blocks, which blocks it is understood? Above two blocks are in series. So we will eliminate those series blocks. Just multiply the gains, it will turn to be a single block. So I will write it. So 1 plus G4H2 into, just I am eliminating, just I am multiplying, that's all. G1 G2 minus G1 G3 divided by 1 plus G1 G2 H1 H2 minus G1 G3 H1 H2. Multiply this and this will become a single block. Is it fine? So the input is R, and sorry, here it is output C, right? Okay. Now I am getting the single block consisting of transfer function, right? So the transfer function is, I have to write, the transfer function is equal to, what is transfer function? The ratio of output to the input in the Laplace domain, assuming all the initial conditions to be 0. So C of S by R of S is equal to this entire thing. This is the transfer function, right? So let me write, no problem. 1 plus G4 into H2 into G1 G2 minus G1 G3 divided by 1 plus G1 G2 H1 H2 minus G1 G3 H1 H2. Yes, this is the transfer function. So we obtain the transfer function by using the block diagram reduction technique. If you want to match this answer with the textbook answer, then you have to multiply and simplify it. 1 plus g4 is to multiply and simplify it, that it matches with the textbook answer. But no need to multiply and simplify it. We will leave the answer here only, right? If you want to get exact textbook answer and match it, then multiply and simplify, right? So this is the transfer function by using the block diagram reduction technique. Okay. If any doubts, please unmute yourself and speak to me, because if I take up the second problem, it will be another half an hour. I have invigilation duty, so I have to leave now. So I'll stop recording.